Good morning, everybody, and thanks for joining us for Dome to Home. My name is Tara, and I am a planetary scientist and a presenter here at Fiske. We also have Amanda here. She's our navigator today, our spaceship captain. She'll be flying us around and showing us all kinds of awesome stuff, and it's all done live. Everything you see on the dome over here on my right is being controlled by Amanda. Now, we also have our friend Emily here. She's not on camera, but she's going to be monitoring the chat and helping us keep tabs on any questions that might come up. So if you have a question, use the chat feature here and let us know, and we'll try to get to as many of them as we can. All right, so this week we're celebrating the 50th anniversary of Earth Day. Did you guys know it's going to be Earth Day on Wednesday? Yeah, it's pretty cool. So Earth Day is a holiday where we take time to recognize and appreciate and show our love for the Earth. And we can do that by like planting a tree or picking up trash in your neighborhood, tons of other ways. But one thing Earth Day also focuses on is recognizing how humans can harm the environment as well by polluting our water and land and air, and nobody wants that. So Earth Day is also about protecting our natural resources. Now, probably one of the most important natural resources is our atmosphere. Do you guys know what an atmosphere is? Yeah, an atmosphere is all of the air that surrounds the Earth, the air that we breathe. So how about we all take a deep breath? So that's atmosphere that you're breathing. So obviously the atmosphere is really important because it allows us to breathe, us and all the other animals and plants that need that air to live. The atmosphere is also what gives us our blue skies, like you see right over here in the dome view. Now, right now, we've got this beautiful picture of Farron Field here at the University of Colorado. Look at that blue sky and the green grass. Doesn't that look soft? In fact, how about we lay down in the grass right here?
Yeah, let's go ahead and lay down so we can get a great look at this beautiful blue sky and maybe something else up.
Amazing. Isn't that nice? So yeah, it's the different gases in our atmosphere that are part of what gives us these beautiful blue skies. Now here's a question for you. What do you think the sky would look like if we didn't have an atmosphere? Think about that for a second.
That's a great question. Our atmosphere is made up of a bunch of gases. So what would it be like if we didn't have those gases? Maybe that's another way to think of it.
Yeah. Hey, Amanda, can you maybe turn off the atmosphere? We can see what it would look like. Look at that. She's like a wizard. So you can see our blue sky is gone, but we still have some light. The sun is still shining on us. The sky would be dark, but the Earth wouldn't. And that's what it would look like if you lived on a planet that didn't have any atmosphere too. And we're going to talk more about other planets in a minute, but let's get our sky back first so we can all breathe again.
Whew.
Are we good? Everybody's okay? All right, great, because now we have an even cooler trick for you. We're going to leave the Earth entirely. Is that okay with you guys?
I think that sounds like a pretty good time to me. Let's do it.
For Captain Amanda. Let's get in our ship. Everybody hold on. So there is our big, beautiful Earth right underneath us. And you can see it's got that light blue line going all the way around the outside. That's our atmosphere. That's what it looks like from out in space. Now, there's one other thing that our atmosphere does for us, and that's help keep us warm, like a big blanket. But it's actually more like a greenhouse, because the atmosphere lets in the warmth that receives from the sun, but not all of that warmth can get back out. So maybe you remember a time when you got into the car in the middle of the summer and it was really, really hot inside. It's just like that. Now we call that the greenhouse effect. And there's a lot of different gases in our atmosphere that we call greenhouse gases. These are gases that are really good at trapping that heat near the surface, and that makes it warm and comfortable for life here on Earth. But some of those greenhouse gases are a little too good at their jobs. Our atmosphere generally is good at keeping itself in balance, but for the last few hundred years or so, people have been doing things that change the atmosphere and throw off that balance. In particular, we've gotten really good at producing a lot of extra carbon dioxide, which is a very powerful greenhouse gas. Here's a great picture. You can see the red parts are where there's way too much carbon dioxide. The blue parts are where it's a little nicer, probably over the ocean where there's not a lot of people.
And remember earlier when we were back on the Earth, we took that really big, deep breath and we let it all back out. And that was, we were breathing in our atmosphere. And when we breathe out, we're breathing out a lot of carbon dioxide, just like you can see right here.
Yeah, and that's what I was going to come to next, is that our atmosphere normally has a little bit of carbon dioxide in it. That's what trees breathe. They breathe in the carbon dioxide and breathe out the oxygen. Then we breathe in the oxygen and breathe out the carbon dioxide. And so that's how it all keeps in balance. But if that balance gets upset, then we have too much carbon dioxide, we get too much heat from the sun, and that's really bad for everybody. So having just the right amount of greenhouse gases in the atmosphere is great, because that allows all the living things to exist here. But besides just the atmosphere, there's another important feature of our planet that allows us to exist here. And that's where the Earth is located in the solar system. In fact, let's have Amanda fly us out away from the Earth so we can see our whole solar system. That white line there is the orbit of our moon. That's as far as any person has ever gone. Now, while we're flying out, I see we have a question from Stephanie. Stephanie wants to know, if the sky scatters light and the sky is blue, is the sun's light blue? And that is an excellent question. That is one that we get all the time. The sun's light is not blue. Well, the sun's light is technically all colors. It looks white. If you mix all the different colors of light together, they look white. But there's still all of those different colors there. Like maybe you've seen light that comes through a prism and splits up into a rainbow, and you can see all the different colors there. All of those different colors are in the light that comes from our sun. We just see them all at once and it looks white. But if you have some sort of special material or some sort of apparatus that can split up those beams of light, you can see the different individual colors. And that works with gases in our atmosphere too. Some of the gases have tiny little particles that will bend that light or push the light off one way or another. And so you're seeing a different part of the light instead of just all of the white stuff. You're only seeing the blues, if that makes sense. I hope that answers your question, Stephanie. All right, so now we're out here at the edge of our solar system. You can see the orbits of our planets there. You want to say them with me? We've got the sun in the center, and then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So those are all of our major planets right there close to the sun. And about our sun is a star. You probably already knew that. But the thing about stars is they're really, really hot. So you know how the sun feels really hot some days here on Earth? And Earth is really far away from the sun. But it turns out we're at just the right distance for life to exist here. If Earth was closer to the sun, it would be too hot to live. If it was farther from the sun, it would be too cold. So we are right in the middle. And scientists call this the Goldilocks Zone because it's not too hot, not too cold, just right. Now you can see from our picture here, we're kind of the only planet in our Goldilocks zone around our sun. But we're not the only planet with an atmosphere. Lots of planets have atmospheres and even some moons, but they aren't all atmospheres like ours. So now we're going to travel to our two neighbor planets, Venus and Mars, and look at their atmospheres and how they're different than ours. Now, first up is Venus. So which way is Venus? Is it closer to the sun or farther? Yeah, it's closer in. So we're going to head that way. So because it's closer, do you think it's going to be hotter or colder? We'll see. And while we're waiting, Emily, are there any good Venus questions coming? Maybe not yet. We'll wait till we talk about it a little more.
You know, it's one thing I've always wanted to know about Venus is what the heck are those thick clouds? And I bet Tara is going to get into that.
Yeah, we are definitely going to talk about the clouds at Venus. Here it is up on our screen. You see that big white stripe kind of right behind it? That is our Milky Way. If you're ever out at night and somewhere really, really dark, sometimes you can see the Milky Way from here on Earth. It's really cool. I didn't see that until I was like way old, so it's pretty exciting. All right, so this is Venus. So do you notice anything about Venus right off? Like, do you see any oceans or continents or really anything at all? Or does it just look like clouds? It's because it is. Like Amanda said, you can't see the surface of Venus. It's just too cloudy, and it's always cloudy over the whole planet. Venus has a really thick atmosphere, so thick that you can't see through it like you can with Earth's. And the Venus atmosphere is almost completely made of carbon dioxide, CO2. CO2 makes up about 90% of the atmosphere. But the rest of the atmosphere is acid. How crazy is that?
And didn't we send a probe to Venus, Tara?
Well, the United States has not, but the Russians have sent some probes to land on Venus. They sent a lot, and only a couple of them actually made it through. Because Venus has that really thick atmosphere of carbon dioxide, it traps a lot of the heat that gets to the surface. It's also closer to the sun, so it's getting more heat to begin with. So it is really hot. So how hot is really hot? What do you think, like 100 degrees, 150, million? It's not quite a million. But the surface of Venus is about 830 degrees. So it's so hot that there's no liquid water or ice or anything on the surface. There's just rocks. And that's what you see in these pictures here. These are two pictures from the Russian Venera landers. Venera is the Russian word for Venus. In the 1970s, they landed a couple of crafts on there, and the poor little robots lasted just about long enough to take some pictures and get some measurements with their instruments, about an hour before they pretty much just fried up. It's just way too hot. So thanks to Russia, though, we have these awesome pictures, and you can see that Venus is just really rocky. There's not a lot going on there.
Do you know how long it would take to cook a pizza on Venus?
How long would it take?
It would take 90 seconds for you to cook a frozen pizza on Venus. And after those 90 seconds, not only would your pizza be cooked, it would be burnt. So it is super hot.
I don't want burnt pizza. I was about to say, I like pizza. I like pizza a lot, but I'm not going to go to Venus for pizza. That sounds a little...
Probably wouldn't be the best.
No, nobody wants burnt pizza. So that's Venus. Venus is kind of like our twin a little bit. It's about the same size, but it also shows us what would happen if we let that carbon dioxide in our atmosphere get out of control. We definitely don't want to do that. We don't want it to be 800 degrees here on Earth. So now Amanda's taking us out of the solar system again, and then we're going to come back in to look at Mars. And this time we're going farther out from the sun. And while we're flying around, we see we've got some questions here. Arnaldo says, my teacher taught me Venus is a rocky planet, but you're saying it's mostly made of gas, like the gas giants. What is the difference? So maybe I think we misunderstood there. So Venus is a rocky planet, very similar to Earth. It just has a really, really thick atmosphere. So just like the Earth has an atmosphere, it's still a rocky planet, but it has gas on the outside. Venus is the same way. It just has a lot more gas on the outside. It's a lot thicker and heavier and gross. Whereas the gas giant planets like Jupiter and Saturn, they don't have that rocky interior. They're just all gas. Now, it's a little complicated in the middle. We won't get into that, but they don't have the same kind of rocky planet in the center. Excellent question, though. All right, so we're coming up on Mars here. So do we see any clouds here like we saw at Venus? Do we see any clouds at all? Not really. That's because Mars has a very, very thin atmosphere. It's only about 1% of the amount of atmosphere that we have here on Earth. But we don't think it was always that way. Scientists think that Mars used to have an atmosphere that might have been a lot like Earth's. It would have been thicker, made up of similar gases. And so we think that Mars might once have looked a lot like Earth. It could have had oceans and continents, maybe some sort of life. We don't know. We do know, though, that something happened that caused Mars to lose its atmosphere. And so being farther from the sun than we are and having less atmosphere means that Mars is really, really cold. It's way too cold to have liquid water on its surface. It does have ice, though. Mars has ice caps at its north and south poles, just like the Earth does. But it's so cold that it's not just ice made out of water. They also have ice made out of carbon dioxide. It has to be really, really cold for carbon dioxide to freeze. How about we land on Mars for a second and see what the surface looks like?
We are going down.
All right. So we're down on the surface of Mars now. You can see it's got a lot of rocks too. There's some mountains out in the background you can kind of see, and kind of bluish skies too. But we don't see any like water or trees or life or anything. Now this picture is from a NASA rover called Curiosity. You guys heard of Curiosity? Did you know Mars is the only planet in the solar system that's exclusively inhabited by robots? At least as far as we know.
Ooh, we'll have to go join the robot planet one day.
Yes. But you can also see that even with a very thin atmosphere, it's enough to give color to the sky, and it holds in some heat. The average temperature on the surface of Mars is about -80. But there are some places near the equator that can get above 0. And guess what Mars's atmosphere is made out of? Carbon dioxide. It's everywhere. So what's left of Mars's atmosphere, luckily, is a really powerful greenhouse gas. So Mars isn't quite as cold as it might be otherwise. And that's why people think that this is a great place to look for life in the solar system. Now, any life that did live there would have to be able to breathe that CO2, kind of like plants here on Earth, but it might not be animal life like what we're used to. It would also have to be super tough because Mars does have enough atmosphere that it gets really windy. And sometimes it'll cause dust storms that cover the whole planet. This would be a really tough life on Mars. In fact, Jocelyn here has a question that says, aren't people trying to colonize Mars? How could we ever live there? That is an excellent question. And people are super excited about trying to live on Mars. There's a lot of different ideas about how we could do this. Most of them involve building habitats there first. We couldn't just live on the surface and walk around like we do here on Earth. There's no afternoon strolls on Mars. But we could build little habitats. We'd have to stay inside all the time, kind of like we do now. So we're getting used to it, you know? But there's a lot of ideas about how we could maybe build habitats to live on Mars. It's an excellent question. There are also some people who think that we could do some things to change the atmosphere of Mars so that it would be more conducive to people, so that it would be warmer, more oxygen for us to breathe, things like that. Now that's a lot harder to do. And there's a lot of people who are experts in the situation that think that it can't be done, at least not in the amount of time that humans have to live there. It would take a lot longer for us to change the atmosphere. It'd be a lot easier for us to just build stuff on Mars. But that comes with its own complications. Excellent question. We do have just a couple more minutes if anybody has any other questions. Let's see. That's a cool picture, Amanda. Is that a Mars habitat?
It sure is. Yeah, maybe one of the pods that we'll build one day will look like this.
That would be super cool. I've heard people say that instead of us shipping things to build stuff on Mars, we should just ship a bunch of 3D printers out there and have it use the dirt and stuff that's on Mars to 3D print its own habitats. So then by the time people get there, it's already all built for us.
Yeah, so maybe you guys can think about what kind of stuff those 3D printers would have to make first.
Yeah. What could you make only using the dirt that you find on Mars? Ooh, here's another good question. Could we change Venus's atmosphere to live there like we would with Mars? I think, again, changing an atmosphere is pretty hard to do, especially one like Venus's, which is so out of whack to begin with. Like with the Earth, it's a very delicate balance. And so if you change it even just a little bit, it'll kind of come apart. But with Venus, you would have to get rid of so much carbon dioxide to make it livable for people. And we really don't know how to do that. If we knew how to get rid of a lot of carbon dioxide in the atmosphere, we'd be doing that here on Earth already. We wouldn't have these kind of problems with global warming and things like that. But Venus has a double whammy because it doesn't just have a bunch of carbon dioxide that's sitting there. There are some scientists that think that it's still building up carbon dioxide. There may still be like volcanoes that are active on the surface of Venus that are erupting and putting more carbon dioxide into the air. So we would have to figure out why there's so much carbon dioxide there to begin with before we can even tell how we would get rid of it and fix it to make it livable for humans. Here's one from Zach that says, what about other planets around other stars? I heard there are planets like Earth that can support life. Another excellent question, Zach. I love it. So there are planets around other stars. We call them exoplanets. Here in the picture, you can see this is an artist version of, we saw where our Goldilocks zone is in our solar system, the one on the bottom. But there's another system around a star called TRAPPIST. That's what you see there on the top. And it has 7 planets that we've discovered so far. And you can see that there's 1, 2, 3 of them that are pretty comfortably in that Goldilocks zone in the green area there. So it's kind of hard to tell if they're going to be Earth-like or if they can support life. Because the problem with planets around other stars is that they are really, really far away, which makes them really hard to see. So you have to have amazing telescopes to even be able to see that these little planets are there. So it's hard to say. Earth-sized planets are actually really small too, so that makes it even harder. Most of the planets that we find going around these other stars are usually really, really big, like Jupiter-sized. So Earth-like planets are difficult to find, but we have seen a couple, and we're pretty sure that there's more out there. This is a picture that she put up. Is that Tess? Amanda?
This is Kepler.
That is Kepler. So there's a couple of different telescopes that are looking for these exoplanets. Kepler was the original. He was the OG. And Kepler was out in space for a couple of years. We actually used to do some work with Kepler here in Colorado at the university. We had students that controlled it and told it what to point at. It was really neat. And Kepler pointed at stars across the universe, and almost every star that he pointed at had at least one planet going around. Some had more, like we saw one with 7, a lot of 2s and 3s. And so there are thousands of these exoplanets out there. And we're also have just launched a new telescope into space because Kepler unfortunately reached the end of his life. But we have a new one called Tess. And Tess is out there. She's got a lot better technology, some cool new tricks. And so we think that Tess is going to find us even more exoplanets. And Tess, combined with another new spacecraft called the James Webb Space Telescope that's getting ready to launch, those are specifically built to look for things that are very tiny and very far away. So that might be a good chance for us to find some more of those little Earth-sized planets, things that might be habitable for people like us. So stay tuned. We never know. We haven't seen anything yet. Those are some great pictures of the new James Webb Telescope. You can see in that one in the bottom how tiny the little people are next to that big old telescope. Isn't that cool? We're pretty excited about that one. It's going to tell us some really neat stuff.
Yeah, you'll get to learn more about telescopes like this next week with the Hubble Space Telescope.
Yeah.
And also, if you guys enjoy learning about exoplanets, we might talk about them in the coming weeks. We're going to talk about we're going to do a tour of the solar system. We're going to talk about other stars and other galaxies. So if you guys are interested in this topic, there's definitely going to be more content for you coming.
Absolutely. Exoplanets are very exciting right now. Lots of people are super stoked. And Lily wants to know if humans could go to those planets to live in the future. Maybe. Again, they're really, really far away. It's a very long way to even the closest star. If we were traveling at the speed of light, it would still take us almost 5 years just to get to the closest star. And we can't travel anywhere near the speed of light. So with our current technology, we can't get there. But maybe if one of you studies your math homework really hard and works at physics and does some other really important things, maybe you could figure out how we can get that speed of light travel, or maybe faster than light travel. I don't know. All right, guys, so we are just about out of time now, but thank you so much for tuning in and hanging out with us today. Thanks for all of your awesome questions and chats. Just another reminder that all of these Dome to Home shows are recorded and they're going to be available here on the Fiske YouTube channel. And definitely be sure to join us next week where we're celebrating 30 years of the Hubble Space Telescope. It's going to be really cool. So same time, same channel. We hope to see you then. And so for me and Amanda and Emily, we'll see you next time.
Thanks, guys.